All right, it looks like the pace of new attendees has started to slow down a little bit, so we'll get started here. Welcome, everybody. My name is David Pedrick, and I'm with Ekotrope. We also have Patrick Nachlas and Sarah Bullock here. They'll be here assisting for the webinar today. I'm a product manager here at Ekotrope. I've been spearheading some of our work around new features like scenario modeling, as well as some other features that we've been working on that you've probably heard about as well. Today, what we're going to do, well, first, Patrick's our account manager. So if you have an Ekotrope account, he is your kind of point of contact, and you probably know him well at this point. And Sarah is in charge of marketing here as well. So she's been a big help for us, and we're happy to have this team here. Our goal of today's session here, we've called it office hours. It kind of grew to be a quite large office hour, which is really cool. And we have this tool called scenario modeling. And what it allows you to do is model many different what-if cases for a set of energy models to plan how homes can meet a new energy code by testing lots of different types of designs for those homes really quickly. Or it can help you understand what the impact of like one change is across a bunch of different energy models. In the cases where a builder calls you up and says, hey, I can't get this product, I can't get this whatever, am I still okay? And our goal with this, these office hours is to help demonstrate how this works, show you how scenario modeling can help you answer those questions so you can get more familiar with it. And to do that, we thought we would have a session like this that ideally is somewhat frequent. And we take suggestions from the audience of projects that they or analysis projects that they have and they're working on right now, and taking it and showing how it can be done using the scenario modeling tool. So this is the first one we've done. We've had a few submissions through the form already, and we're really excited to show you some of those with a little bit of tweaks, as well as other analysis projects that we've seen people do. And if we continue to get lots of good kind of feedback and suggestions for different analysis projects, we'll keep this going. It'll become a regular thing. And we're excited to do this and show off this tool. So with that, before I get started on one project, the way this is going to work, I'm going to kind of describe what the project is, what the goal is, what the mission that they're trying to achieve is, and I'll go through and show you how it's done in scenario modeling or analyze it. I don't really know what's going to happen because I'm using this live. I've not done any pre-analysis, so it's going to be a very realistic use case of how this works. Throughout, if you have any questions or suggestions, please put them in the Q&A form or in the Q&A section of the webinar. And if you have any analysis projects that you would like to talk about or like to see if scenario modeling could help you with, put those in the chat as well. And we will work through analyzing those, reading those, and work on answering any questions you have throughout the webinar here. So with that, we're going to dive into this first one. And what the two types of analysis projects that we generally see people doing with scenario modeling, I'm going to start sharing my screen here, not that button, is these two situations. One situation is when you have already built a set of energy models for a subdivision or for a multifamily building, and the builder calls you back and says, hey, I know I sent you these specs, but what if we made a change to the specs like this? Or would it be better if I did this? And those questions, we know that they happen a lot. Those callbacks of, hey, did you check this? Did you not check that? take a lot of time because you've already invested a lot of time building that energy model. And now they ask you, what if we change this one thing? And you have to apply that one thing across all of the energy models to say, would they still meet that energy code or that rebate program or that third-party program that they need to meet for those homes? So we have some example projects pulled up here. And in this case, there's 4 projects. And currently, they all meet the Texas 2015 ERI code. And what we're going to do is we're going to look at these energy models a little bit, and then we're going to say the situation that's come up for this specific problem is there's a few different scenarios. One, the builder couldn't find radiant barriers, so they need to say what is the impact of not having radiant barrier. The other situation is they couldn't find the same types of windows that they had originally planned for. And another situation is they couldn't find the same water heater that they had planned on. So they're looking at what if we change the water heater. And then finally, the last one is like, what happens if the infiltration is a little bit different? So I'm going to show you how scenario modeling is done in this case. And usually as a energy modeler, you have a pretty good understanding of what's in these energy models to begin with, because you already built them, right? You've spent a bunch of time, probably an hour or so, doing takeoffs and entering in those energy models, so you have a good idea of what the baseline case is already. So to start scenario modeling, I'm going to select these projects. I've already filtered these. Coincidentally, Robert Reed was my former boss, which is just a coincidence here. And we come up with scenario modeling. And I was talking about how you generally know kind of how these projects were built originally. I know very little about these projects. So Patrick, could you go in to one of these and see what the attic insulation is? So I know how to switch that up. So yeah. So this first screen is to define the design changes. This is what you want to actually change in the energy model. You'll notice all these different settings on the side over here are the different pieces of the energy model. And I said that in this scenario, we're imagining, or in this case, the builder has called up and said, hey, for my Robert Reed energy models, I can't get those same windows that you modeled, but these are the windows I can get. Do I still meet the 2015 IECC or 2015 Texas ERI? So what we're going to do here is we're going to model that. We're going to say, let's come down here to Windows, and we're going to say the builder could only get 0.3 to 0.28 windows. And what this is actually doing is this is searching your component library for all of the components in your Ekotrope account. And I don't know if I actually have a 3228 window. Actually, I do right here. And this is a design change number 1. So when I apply this, it's going to change the windows that are in the energy model today to this window. I know that the windows in this energy model were originally 0.3, 0.23. So this is a little bit worse window. And that's kind of the value of this here, is that you already had this energy model fine-tuned to just meet energy code. And now the builder says, I need to actually install worse windows. And this is going to help us understand how much worse does it make the home? Does it make it 2% worse? And it's going to tell us that for all of the energy models that we just made. That way we can then come back and say, okay, it's 2% worse. Where other piece of the energy model do I need to push and pull in order to get us back to that energy code compliance? So on this screen, we can do one, but we can also model up to 15 different changes. So we're going to imagine the builder calls back again and says, hey, actually, I can't get radiant barriers either. And in that case, we're going to come down here to ceiling roof, and we're going to apply this to all of the ceilings in the building, in the home. And Patrick, what's the what's the R value of the existing roof in this house?
It's R38 blown cellulose.
R38 blown cellulose. So I'm gonna look up, find my R38 um, right here. And it says with, so I'm gonna look at this one quickly. It says this has a radiant barrier. And what we're trying to model is what would be the impact if it didn't have a radiant barrier. So we don't want to have this checked. So I'm actually going to copy this because I can make and change components here. And I'm just going to call this without radiant barrier, uncheck the has radiant barrier, save it, and that's my design change. There are some of these design changes that you can specify. Do you want to change all of the components in the energy model or just specific components? And you can say only things that are exposed exterior in this case, or unconditioned attic. I'm just going to say all components and update them all. So let's add another one. The other kind of situation here that's happening in this home is the builder says, hey, I can't get the same water heater that you spec'd. And they want to know what the impact would be. The original water heater was a 0.89 water heater. So I'm going to come in here to mechanical equipment.
I believe it was 0.93, David.
Oh, 0.93. There we go. Yeah. Thank you, Patrick. And I'm going to say what happens if we change that 0.93 to 0.89. And I'm going to say residential water heater, 0.89. Was it natural gas, Patrick?
No, it was electric.
Was electric.
Yes.
And I can't see this. 0.89. And is it a 50-gallon tank?
Yeah, 50 gallon. Yeah, 50 gallon 0.93.
So now we're starting to build a bunch of different cases here. You can imagine that this would actually be individual calls, and you'd be doing this multiple times because the builders don't often think of the same thing all at one time, and they call back multiple times to check on things. And the final thing that this builder in this situation called back for was you modeled all these homes at 3 ACH. I'm not comfortable committing to 3 ACH. So can you model it at 3.5? So we're going to come over here to infiltration. We're going to say update all of these to 3.5 ACH. And I'm going to rename this as 3.5 ACH 50. And now we've covered all of these situations where the builder called us and said, hey, we can't do this. What will be the impact if I don't do that? And we're going to move on to the next step here. So the next step is moving on to scenarios. And the first one is design changes. In this case, in this situation where the builder has just called us and said, what if we don't do this one thing? The scenarios are going to be pretty simple because you're just going to say green means it's on. And we're going to say what happens if we make this change. And we change the windows from what they were to this new component here. And you can do this over and over again. You can have any combination you want as well. I'm going to remove this one and take a shortcut and say add each one as an individual design change. So it names them for me and it sets them all up like this. And then just for the heck of it, I'm going to add them all together and say, what if we made all of these changes at the same time? Because the builder, they may maybe call it individually 4 different phone calls, but now we've made 4 total changes. So let's put them all together here. So the other thing, if I was like doing this in the for real, I would be modeling these things that make the energy model worse, but I would also be adding some things that slightly improve the energy model at the same time. That way I can be combining these things into one step where I say, the builder just called me and he wants to make the energy model a little bit worse. I'm going to go ahead and hedge my bets and say, I think they're probably going to have to do some little incremental things here and there to make up for that loss. And if I put them all in together here, when I press run, I can get all those results at the same time and say, cool, your loss of your worst performing windows decreased your performance by 2%, but I went ahead and modeled this other factor that brought us back to where we need to be. And so you can put that all here in one go and have all those results. So let's go on to results. We have a bunch of different energy codes supported here. Anytime a client asks us for a new code, we can add it pretty quickly. And these homes are in Texas, and we know that the builder cared about the Texas ERI, which is unfortunately one that we don't have here. But we can throw in the 2015 ERI, which is the basis of that Texas code. And we're going to throw in HERS index for the heck of it here as well. And what this is going to do is it's going to evaluate the change in performance from the baseline code, or the baseline situation of these energy models. We're going to go ahead and review and submit. So this screen gets a little bit crowded sometimes, and let me maximize it. And so we have 1, 2, 3, 4, 5 scenarios and 4 projects. So it's going to iterate through all 5 of these, through each project, plus a baseline project. So we're actually going to be analyzing, what is that? 1, 2, 3, 4, 5, 6 different scenarios times 4 projects is 24 different iterations here. So I'm going to press finish, and it's going to submit this and start calculating the results here. Once the results are completed, it's going to email me a spreadsheet that will have all of the results in there, and we'll show you kind of how we analyze those from the spreadsheet.
Yeah, David, thanks for walking through that. We do have one question about scenario modeling. Scenario modeling, they aren't seeing it on their in Ekotrope. That's because it's not yet available. It's not available to the baseline user. It is a premium feature, so there is a additional fee associated with scenario modeling. But the idea is the time savings will justify that, the time savings in analysis. So that's the answer to our question here.
Yeah, so thanks for answering that question. I just got the email from the results, and here's a spreadsheet for all of the results. You'll notice that this, we have 24 rows of results over here, which is that 6 times 4 math that I just did. That was right. And we have, it's a big data sheet here. So there's a lot going on here, and let's look at this individually. I'm going to expand this column, and we have project name. So you'll notice that we have 4 different projects here, just like we started out with. And for each project, it's repeated multiple times. And that's because if we look over here at the scenario ID for this project, let's highlight it like that. We have the baseline project, then we have a copy for each individual scenario that we just created and we just analyzed. And on each one of these rows is the result of the analysis. So I'm going to scroll over to the right here. We have some information about these homes: the plan name, city, state, the weather location, square footage, and volume. So that maybe you want to group your results by residence type. You'll notice we have some townhomes and single-family homes here. So maybe the results are slightly different based on that, and you want to analyze it like that. I'm going to hide these for now, and we're going to come over here. And right now, you'll see that we have the HERS score listed and the change in the HERS score. We have a lot of significant digits here, so you can see even small changes in the HERS index. Even though we know that the HERS index is rounded, we still want you to see that a change in the windows resulted in a 0.095 change in the HERS index. If we rounded that, that would go to 0. But so there is some change here. In the HERS score change, the change is always going to be compared to the baseline case, like how the energy model started from the baseline case. And we can see that actually this window The original HERS index was 57.8, and the new HERS index is 57.7. So this window actually made it slightly better, even though the UNSHC value changed. The interaction of heating and cooling degree days, as well as the material of the window, changed a little bit. So we have some kind of interesting results here to look at. So this is what it shows up for the HERS index. Some of the other things that we have here are energy code compliance. Energy code compliance gets really interesting because there is always going to be a pass-fail component of it. Did you pass or did you not pass? And that turns into a really bad metric to show how much a scenario impacts the performance of a home, because if you're only measuring, did this individual thing get me to pass, you're missing a lot of detail, because maybe it got you closer to passing. And in order to see whether or not it got you closer to passing, we have this thing called the buffer change. The buffer is how far away the energy model is from passing a particular energy code. And this buffer change is going to show how much did that buffer move for this scenario. And the buffer change here is going to be a measure of, for an ERI code, there's an ERI target to comply with energy code. And the buffer is going to be the percent difference between the target and this home and this scenario's particular ERI as well. So we can see some results here, and what people normally do once they have these results, they select all and they put them into a pivot table to make them a little bit easier to compare across all of the different scenarios. We're going to open this up, and really basic pivot tables here allow you to make rows and columns from the data that you just selected. And you have all of your options, which is all of the column names in this list here. Usually what people do is like to add scenario name to the row labels, and then come down and pick one of the performance metrics and see what the average is across all of those scenarios, so that you can see, okay, all of our energy models are slightly different, but let's see what the average impact of this one particular scenario is, to see, did that make us better or worse, and how much better or worse did it make us. The other things that you do a lot are, say, we did this particular scenario, and to start out, 100% of the energy models passed a particular code. Now let's look at scenario 1. Now 80% of those energy models pass the energy code. And then you can go and look at that specific energy model. How close are we? Do we need to, are we really close or really far away? Is there something that we can do to make a small change for that specific plan? Is the builder willing to do that for a specific plan? Or is there a small change that will improve it just enough in all of the others as well? The one thing here that we have is, first, it usually does sum. So we're going to change that by just telling it to calculate the average. And here we have the average HERS score for each of these. And we see that the baseline project had a 58.7 average HERS index. And we can see that all of these changes had pretty small impacts. In total, scenario 6, the average was 59.3 compared to the 58.7, or 59.4 compared to 58.7. And let's see here. We also have HB 3215 over here that we can bring in as well. So this is what happens when you pick audience suggestions. We don't actually have the same energy code supported here as we were looking at to begin with, but that's fine. That's kind of the point of this, is to learn. And whenever a client adds scenario model, we ask what energy codes are most important for your analysis, and we can add those when you sign up and have those available to you. So here we can see that the target score is 59 and HB 3215, all of these score 59.25 or 59. We have a 58.75 here for each scenario. So I'm not exactly sure how rounding works for this particular code, but these that round down to 59 would be at or below, and these that round up and these round down. So we can start to see that which ones pass and which ones fail this energy code that way as well. So if the builder called me and said, hey, what happens if I move to 3.5 ACH or install this water heater, I can do this analysis for I just did 4 energy models. Maybe they have more energy models. And I could practically on the phone call with them say, if you move to that water heater, your HERS index would increase by 0.6 on average, and your HB 3215 ERI would be 59.25 on average. And then I could add in project ID here. Actually, just let's do a project name. It's a little bit easier. And look at each individual one. And I could say that actually this project, Abilene B, won't pass 3215, but we're good on the next two. And the last one, Abilene A, also doesn't pass. So while I'm on the phone with the builder, I can say, okay, half of them are still good. The other half we need to figure out a solution for, and give me 20 more minutes. I'll test a couple different options and send it over to you to tell you what the options are to return back to HERS 59. With 4 projects, depending on how many design changes you want to do, it could take not too long to do it by hand. If you're doing a lot of design changes, it could take a long time. But if you're looking at 20 different plan types, or 10 different plan types, it starts to take a long time to iterate through all of those. So scenario modeling does it really quickly without having the risk of making a mistake or changing a library type that may cause kind of unintended consequences. So if the builder does end up making this change, you would still need to update these energy models with that change that they've just suggested for you. So if that's the case, that you need to you want to make the change to the energy model, we do have a description of the scenarios here. And as long as they're named well, you can send this into as a custom batch mod through the batch modification widget in the app, and send that in, and we can you can make the change in batch mods because most everything's covered there, or we can make the custom batch mod for you to go and apply these scenarios really quickly for you, so you don't have to go back and make those all by hand. All right, Patrick, there's some questions.
Yeah, there are a couple questions. One question is this product only available to raters through providers, or can individual raters access this?
Yeah, so it's available to any rater. Some providers are prefer to have Ekotrope sell directly to their raters, so you can just contact us and purchase it from Ekotrope. Other providers, they are being resellers to their raters. But if you have any questions or interested in adding this, just give us a call and we'll help you figure out if you need to go to a provider for it or through us. Same price in both places.
Great. Yeah, and then this other question I think is something we'll be able to show on the next scenario here. Can you combine scenarios? Which we can show how to do that. And lastly, one thing I do just want to say, today we're showing what happens when a builder, can't access a certain material, and we're also showing, hey, what if a builder wants to meet a certain code? Feel free also to suggest any other use cases that you think a builder might be interested in, or you would be interested in using scenario modeling for. Those are just the 2 ones we've seen happen the most. We'd like to hear any feedback on that as well.
Yeah, great. So we'll move on to this next project that we got. So I just went and filtered for this project name here. I got four energy models again. We're going to go through here. We selected these four, and in this case, Ashton Street, they currently meet Energy Star version 3.1, which is great. But this builder plans on um, building this same plan for the next year or two, at which point they will need to meet Energy Star version 3.2. So they're going to be a little bit harder to meet that program, and the builder needs to know how they're going to do that. What different specs are they going to have to build for these energy models? And we're going to try and develop a plan for them to do that. Some of those things are going to be maybe Energy Star specific to checklists. I'm not too sure on that. Other things are going to be actual changes to the building in the energy model. And if you have any ideas for different things you want to see tested for these homes, I know when I've talked to raiders and they do this, they usually have kind of a toolbox of changes that they usually try. And that toolbox is filled with ideas that this builder is willing to do, or that has generally worked in other cases, and you're willing to kind of suggest to the builder. And that's usually kind of a list of 15, 20 different things that you end up trying on all of them. And one of the next things we're going to add to scenario modeling here is the ability to save those to scenario modeling. That way you can just load them in and just say, yes, I want to do all of those. Because what we've learned is that they're fairly consistent once you've kind of developed your toolbox. And on this screen or someplace else, you'd be able to say, yes, start with all of those, and then let's make some tweaks off of that. In this case, what we're going to try here is this home has supply only, this builder does supply only ventilation, and we're going to update it to an ERV. So we're going to come down here and come to mechanical ventilation, and we're going to say, let's update it to an ERV with 66% recovery efficiency. Some of these fields can flow rate be measured and operational hours per day. We can update these to whatever we need, but you'll notice that there isn't an actual data point for how much CFM or how many watts this ERV uses. We don't have that in scenario modeling because these homes are all different sizes. And because they're all different sizes, they have all different air leakage or infiltration rates as well. And so if you set the design airflow and the wattage, it's not going to be quite perfect for all those different homes. So instead, we have a calculation here where you say, set the CFM to be 62.2/2013, and then we'll calculate the default wattage here for these homes as well. So I'm going to change the name over here to 66% ERV at 62.2/2013. And then we're going to add another design change. We're also going to update attic insulation. And this home currently doesn't have much insulation, so we're going to add a little bit more. And we're going to go ahead and just say R49 blown for all components. We're going to move on here. And Patrick, is this one that we wanted to work with mechanical systems?
Is this Ashton Street?
Yes.
No. This was a maybe a continuous insulation. Adding that potentially.
Oh yeah. All right. So as you can see, all these changes are based on your component library. So we can come in here and find any type of wall assembly we want. Say it's a 2x4 now, but let's say let's update it to 2x6 with R for continuous. And we're only going to update exposed exterior walls. Uh, Garage walls, we're going to leave the same. Adiabatic walls, we're going to leave the same. We're just knee walls, we're going to leave the same. We're just updating exposed exterior. Let's go ahead and add mechanical equipment here just to kind of show how this works. We did one with water heaters, but let's go ahead and update this. Let's say this is an air source heat pump, and it's going to cover cooling and heating loads. We could just model it so it's just serving the heating load. And what this would do would be just updating the efficiency and fuel type and equipment type for the heating, for pieces of equipment that serve the heating load in these existing energy models. So it's fairly surgical here. Patrick, do you have some good ideas for
Yeah,
HSP?
HSPF, let's say 9.
Yeah.
And SEER, let's go ahead and put in 15.
All right. And we're going to call this air source heat pump. Air source heat pump. 9 HSPF 15. All right. Anybody else have any suggestions of things they want to model in here?
I think that's good on components. There are a few questions when we get to scenarios, if we can
Gotcha.
look at those.
Yeah. All right. So we're going to move on to scenarios. So first off, we're going to make the first scenario, and I'm going to say apply all of the design changes. Green means it's applied, and that's scenario 1. I'm going to rename it all design changes.
Yeah, so we had a question about, can you combine scenarios? And I guess the answer to this is yes. So you can, decide I just want to do one change, or you can decide I can do 2 changes or any combination of the changes you've input already. So that's the answer to that. David, another question we had was the evaluate all plans button.
Yeah.
Can we talk a little bit about that? Yeah.
All right, so here I made a bunch of different scenarios. You can make up to 20 of these. You could do every combination you want for 4 design changes. Once you get to a few more, you have to be a little bit more selective there. So we're going to move on to the results. And we said Energy Star version 3.2. So let's just go ahead and check those. First score is always fun to look at. Let's look at DOE. And you'll notice down here is evaluate all plans. This is an option where some rating companies will have multiple house plans in one project. So if you, or multiple building designs in one project, yeah. And what this allows you to do is model these design changes, not just for the primary building design, but for all of the building designs in that project. So you can see what happens. So like maybe each building design is a different elevation for that same house plan, or different options for that same house plan. So this allows you to see what happens if you model that same change to all of those. We'll go ahead and check it. I don't know with these energy models if they have those or not, but we'll find out. I'm going to review. I'm going to finish to get the analysis running. We have a few more scenarios here. 1, 2, 3, 4, 5, 6, 7, plus an 8 for the baseline times 4. So we have a few more. It's going to take a little bit longer to churn through all of those. And then we also have the wild card. Maybe these energy models have 4 building designs, and that multiplies it again. And we start to have lots of different iterations here. While we wait, there will be a notification here that tells us when it's done. You'll notice that the finish button is grayed out, and that's because it's calculating and analyzing it. As soon as it's done analyzing, that finish button is going to turn green, and you will actually be able to go back through here and make any change you want and then rerun it. So it's kind of saved temporarily. And so you could look at the results, analyze it, decide, oh, 15 SEER wasn't good enough. I actually want to model a 16 SEER system. We just see the notification that we got the results. And then you can try this all over again and tweak it a little bit. Like I said, we're working on being able to save design changes. We're also working on being able to save scenario modeling projects so that you don't have to leave the screen open to reanalyze or make those tweaks. You'll just be able to save every single time and come back to it later and tweak it and run it. So if you look over here, we got the green button and we can go ahead and finish and run this again. But let me download the results that I just got.
David, while you get that pivot table up and running, about how many how many projects can be put into scenario modeling at once?
Yeah, we cap it at 1,000 energy models, so you can model as many as you want, basically. And in special cases, we can do more than that if necessary.
One other question we had was, certain programs look at kilowatt hours, therms, BTUs. Is it possible to evaluate these metrics in scenario modeling?
Not right now, but that is the very next thing we are adding to scenario modeling. So in the next, I think, 3 weeks, you'll have all of those data points in scenario modeling.
Awesome.
All right, so let's look at some Energy Star version 3.2 results. As I get this set up. All right. So here, look at HERS index. We see some interesting changes here. On average, the best performing one was this ERV. Actually reduced the HERS index on average by 3 points. So went from a 53 to a 50 on average. If we come over here to Energy Star 3.2 compliance, I've left this at some because 0 means fail, 1 means pass. So if we sum all those up, it'll give us a number of total projects that pass Energy Star 3.2. We analyzed 4 projects, the sum is 0, which means they all failed. And there's a couple of reasons why this could happen, right? This could mean that the HERS index of this home isn't lower than the Energy Star version 3.2 target HERS index. The other thing that could happen is there's a whole bunch of QA checks that happen in Ekotrope, and those QA checks, one of those could fail, which caused this to not pass. But in that case, we also have the buffer. And so, like I was saying before, the buffer is how kind of far away from that target index this home is. And if we look at this, first off, we can look at the base project, and the target index is negative 51, negative 0.51, which is negative 51%. Which means it's a long ways away from passing version 3.2. And let's see here. There we go. Let's put that to percent. Zoom has a little bubble over the places I need to click in Excel. Oh, sorry, these are sums. That doesn't make sense. That's not intuitive. Let's turn that into average. All right, that looks better. And all right, so actually the baseline case is negative 20%. And in this scenario, the best performing one, the ERV, got us to within 7 percentage points of passing. So it helped us improve quite a lot here. But it didn't quite get us to Energy Star version 3.2. So there'd be additional design changes you may want to make. If we look at all design changes here, interesting, about the same performance. And we're to negative 7. So we could dive into this a little bit more and try and diagnose why each of these is doing what it's doing by looking at each individual project. And we only did kind of 4 different design changes. So if we applied maybe 5 or 6 or 7 or 8, and had a few more ideas of where to go, we could have combined all of those together to kind of narrow in on each of how to pass Energy Star version 3.2. We see that one project is actually very, very close, with -2 and a -4. But these two kind of outliers are holding us back. So we probably want to spend some time on those projects to hone in on how to pass. All right, we're at 2:47. Do we have any other questions or about the tool?
Yeah.
And yeah, go ahead.
Yeah. So there is one question in the queue at this point. Will all these components being in scenario modeling, will this have any effect on batch modifications down the line, potentially expanding that functionality?
Yeah, our roadmap is to catch batch modifications up to scenario modeling. So scenario modeling's crept ahead a little bit, and we'll have to return back to batch mods and catch it up. So everything's in line.
Awesome. Awesome. Okay. Another one. What's your favorite part about scenario modeling? What's your favorite feature?
Favorite feature: being able to change mechanical system efficiencies. Um, it's very surgical, so you can change really specific things. You can change just the heating load or just the cooling load systems, and you can also change fuel type as well. So it helps people evaluate electrification as an option.
Yeah. And similar to what David said earlier about kilowatt hours and BTUs, this is very much a living feature. It's going to continue to expand and grow it as we add new functionality. So this is where it is right now, but over in the future we will add new features. All right. One other question we did have was about the price point. This is a premium feature, so it does come with an additional cost. Can you speak to the price point a little bit, David?
Yeah, it depends on kind of your company size and how often you're going to use it. But the kind of starting point is $200 per month.
Yeah. So, a lot of folks have done, time savings assessment to help them determine if it's worth it. How much time is something like this saving? Something else we've heard a lot of folks talk about is that this is a very useful tool when there's upcoming code changes. So, as new codes become adopted, they find themselves doing a lot more of this type of analysis. Um, so, yeah. Or are there any more questions coming through? That's all we have on the list at this point. I know there were some more scenarios, but I don't know if we can get through them in 10 minutes.
Yeah, I think we should hold off on those until next time, and keep an eye out for the next notification of one of these. And our intent is to, if we repeat this, to send out a notification about the webinar so everybody can sign up, and then the week of the webinar, send out the requests for projects that you may have. We know they're timely requests that you need um, to return to clients relatively quickly. So we're only going to start asking for them for a few days beforehand. That way we can work through them together. And if you are, you're probably going to be featured on it a little bit as well, because we want to give you, actionable information through it as well, and hopefully share knowledge across the industry to see how people answer these questions and provide valuable feedback to the clients.
Yeah, I mean, we're trying to do your homework for you. That's our goal with this. So uh, thanks so much, David. This has been great.
All right, thanks everybody, and we'll hope to see you all soon.
Thank you all for joining.
Thank you, everyone. Bye bye.